water cycle. At this point, you probably should be able to draw and label the water cycle with no problem. However, we shall do it one more time to practice. So for the water cycle, let's go ahead and draw. Actually, I'm going to move this down so we can draw it up here. We shall start with some water and some land. Okay, so the first step in the water cycle is going to be what? How is the water going to get away from here? Yes. Evaporation. So evaporation is, of course, powered by the sun. All of the water cycle is powered by the sun. And as the sun shines on the land and the water, you get some evaporation coming up. Let's make it red since it's going upwards. Into the air, creating humidity in the air. It also, of course, evaporates from the land and from the trees. We talked yesterday about the trees increasing humidity in the air. And so it evaporates from all of these sources into the air. Can you see the water in the air? No, it's a gas called water vapor, but really for the most part, you can't see that. What is the next step where that water becomes visible again? Condensation. So the water gets up high enough that it condenses into clouds, which also, so think of fog, that's about what the texture is. And this is condensation, which is down here, condensation, water going from water vapor, gas in the air to liquid in the clouds. And so you imagine walking through fog. It's water droplets, but they're very, very tiny. So then you have these clouds all over the place. And then as they start to move, they oftentimes go up in the air, or if they get just enough water in them, there's too much water to stay in those little droplets. And then what happens? Precipitation, and that would be the third part here. We'll make some rain falling out of here. And precipitation, of course, is rain, snow, etc. And the water falls back to the earth. And then this water fell way up here. Where does it go from there? We get runoff, and where else does it go? Into the ground. So some of it will go into the ground, and some of it will go into streams and rivers. And yes, we call this runoff. And some of it will get down and trickle into little pool in aquifers, whoops, which we'll talk about a little bit later. That's right, because it goes down through the more porous layers like soil and sandstone and sand and that sort of stuff. And then it generally hits either something like bedrock or clay that is too dense to let it through, and then that's where it pools. So that is the water cycle. Again, you should be able to label and draw all of those parts and know condensation, evaporation, and precipitation. All right, so here's another drawing of the water cycle. If you are watching this video, you could use this and label A, B, and C and study using all these different forms. We are not going to go over it now. Yesterday in class, we talked a little bit about the role of trees in evaporation. And as we talked about yesterday, trees increase the evaporation because the roots go deep into the ground, and then you have the leaves. And as we talked about last year, the bottom of the leaves have little stomata. The gas and the water comes out of there. And so the trees are essentially pulling water from deep underground, and then it evaporates into air. And it makes sense. A city or a park or a forest with more trees is going to have more humidity. We already also did the 4 main water sources on Earth. Make sure you know that, which will also be on our next slide. Okay, the 4 main water sources on Earth. But more importantly than that, how is this water distributed? You should write down this pie chart. This pie chart is really impressive. It's important. So salt water in the oceans, of course, is the biggest source of water on Earth. And how much of Earth's water is in the oceans? 97%. 97%. That's a lot, but it kind of makes sense when you think about it. The oceans cover, what, 70-some% of the Earth's surface. So 97% of the water on the Earth is in oceans, which is great, except we can't really use that water for drinking or watering crops or plants or anything. So you take that 97%. So how much water is fresh water? 3%. Not that much. And that 3%, if you break that 3% down into the different sources, this is what you get. Of the 3%, 76% of the fresh water on this planet is frozen. Not very easy for us to use. So that's the polar ice caps, glaciers, and sea ice. So huge amount of fresh water that we can't use. We were talking about earlier, I talked with some of the groups, ice is actually fresh water. It's always fresh water. So even in the ocean, if the ocean gets really cold and the water freezes, the salt gets left behind. So as the water freezes, it turns from salt water to fresh water. You cannot have frozen salt water. All right, then the next source is shallow groundwater, which is 12%. This is the one we talked about earlier as the most important source of water for people to use, shallow groundwater. The ice, of course, we can't use. There's also some deep groundwater, which is really too deep for us to get at. Then we have lakes and rivers. Can we use that water? We can, to some extent, but look how we think of lakes and rivers being a lot of water, but when you look at all the water on Earth, even all the fresh water, it's 0.34% of the 3%. So that's a tiny amount. And then there's water vapor. That's the humidity in the air, which we don't generally use that for what's that? Oh, I don't think that counts as clouds, because water vapor technically is the gases in the air, or the water gas in the air, and clouds, it's condensed a little bit more. So that means clouds aren't here, but the clouds we can't use, and they're constantly moving, right? The clouds are there and then they're gone. They form and they rain. So I think the clouds are a source that's changing so much they just didn't put it here. All right, a couple questions about these sources of water. First of all, the question is, wouldn't all of this salt water contaminate the fresh water? As the water goes through the water cycle, as water evaporates, it goes from salt water in the ocean, to fresh water, because when it evaporates, only the water molecules, only the H2O, can evaporate into the air. The other things, the salt, which is mostly sodium chloride, and all the other minerals stay behind. Just like when we talked about before, if you boil water, sometimes you'll get that crusty stuff behind, the minerals and such that are in the water. They don't evaporate. They're a solid. They're normally dissolved so you don't see them, but that solid can't turn into a gas. And the same thing happens when water freezes. The same thing happens. It goes from salt water, if you're talking about the ocean, to fresh. So when it freezes, the water makes its little water ice structure, and the salt just stays behind. So as the ocean water freezes, the ice is fresh water, and the surrounding water gets a little bit more dense with the salt. The next question was, so the question was, first of all, will that pollute it? No, so not really. And then when you have water, when you have rivers going into the ocean, you will generally have an area that's a little bit salty and a little bit fresh, and we call that brackish water. It's a little bit, it's a mix. It's nasty. But there are a number of animals that can live in those environments. And river deltas and I believe the Everglades have some of that as well. Then the other question, why can't we use either the ocean water or the ice as fresh water? We can, but it takes a lot of energy to get that. So it takes energy to melt the water. It takes energy to boil the salt water to get the fresh water out of it. So we can use those. But you think about, too, if you've ever heard, if you're out stranded in the mountains because you did this awesome snowboard trick and lost your board and now you're stuck, can you eat snow to avoid dehydrating? Why not? Actually, the biggest issue is your body spends so much water, your body spends so much energy warming up the ice into water that it actually makes you very cold. Yeah. So you need to try to melt it first and then drink it, but it actually takes a tremendous amount of energy to melt water or to melt ice or boil water. But it tastes good. Okay. Real quickly, the last question, will we ever run out of fresh water? It is absolutely a problem. We use water for a lot of things, and even though there's a ton of water on Earth, and it's constantly being recycled, the amount that's available for us to use, and as you know, the water we actually drink must be really quite clean. So it is an issue that we have to take care of the water we have. Also depends on where you live. Let's move on to a couple other slides here quickly. We talked, I know we talked yesterday, one of the other days, about watershed because almost everybody didn't know what it was. So please make sure you know the word watershed. It is not a building, it's not a reservoir, but what it is, it's an area of land that water runs off of into the river system. I gave you the example, if it rains here in Louisville, where does the water go? To what? Yes, to Coal Creek. Right? So we are in the Coal Creek watershed. If you look at the United States, here are the three major watersheds: the Colorado River watershed, the Missouri, Mississippi, Ohio, all drain into the Mississippi, and then the Columbia River watershed. So you can see these major. Well, yeah, you see Texas here, and this dry area here is really quite dry, and they don't show them as being part of any river basin. So I don't know if there's smaller ones. You got the Rio Grande here, which I imagine this might be draining into. I don't know. Here in Colorado, which watersheds does Colorado's water go into? The Colorado and the Platte. Which one? The Platte you don't see on here. Well, actually you can see it. Which watershed is the Platte River part of? Yeah, it's here. This is the Platte River right here. So here in the state of Colorado, we actually have two major watersheds. How do you know if the water is going to the Mississippi or the Colorado? Yes? The Continental Divide, yes! Check this out. The Rocky Mountains come through here. Continental Divide and divides the watersheds, right? Excellent. Quick questions. Okay, a couple other things we'll go over quickly. We were talking earlier about some not so scientific terms, such as ocean and sea, and then we also have ponds and lakes. They're part of the surface water system. What's the difference between a pond and a lake? It's really not very scientific, but technically a pond is smaller. I think everybody would guess that. Even a big pond is smaller than a lake. But in a pond, generally it is small enough and shallow enough that the sunlight can reach all the way to the bottom. And lakes are generally much bigger and deeper, and that does not happen. So somebody said, well, what about Harper Lake? Does that mean it's a pond? It could be, but we use that word kind of socially in a very different way than scientifically. And of course, if the water goes all the way through, you get a lot different living things in a pond than a lake. So not a huge deal, but something that we read over. Wetlands, also known as marshes or swamps, and we saw a little bit of this in the video. And one of the worksheets you'll do tomorrow is going to talk about wetlands and swamps like the Everglades. It's an area covered with water during part of the year. And generally what we do as human beings, if we want to build a city or a town or streets and roads, we have a tendency to do things like drain the water out of the wetlands so that we can build there. The problem is those wetlands generally act as kind of a buffer zone between flooding. So if there's a lot of water, it goes into the wetlands and then dries out in drier seasons. Instead, we usually do things like make dams and walls and channels and canals and make the water go where we want it to, which is helpful for us, but then you lose a lot of ecosystem in the wetlands. Moving right through here. Where is the water? Back to the video, the Tim and Moby we were just watching. The ground kind of seems solid, but you've got the permeable layers. The water goes down through the plants and the dirt and the soil. And then at the beginning of class, somebody said, is there dirt in the groundwater? Well, there is kind of. So imagine it being gravel and sand filled with water. If you look at our fabulous water cycle stream table back there, the big mesa area on that does have groundwater in it. And some of it you can see in pockets and some of it's more saturated like a sponge. And then as we talked about, it will get down to this more dense clay area and will stop going down. So then that's the groundwater. And then if you look at this picture, you can kind of see the whole bigger picture of houses drilling wells down into the water table to pump up water. This one shows a well that's now dry. One problem we've had in Colorado sometimes when we do a whole huge subdivision of houses all in one area, if all of the houses have their own wells and they all tap down into the same water system, water table, and then everyone, fills their swimming pools and waters their lawns, you can actually lower this down. And so many cities now have big tanks of water or something like that to store water to make a little bit more consistent source. Questions about that? And the last topic, which is from section 5, talks about treating drinking water. We talked about the fact that the water, even if you just take it straight out of the ground, it might have contaminants in it, depending where that water is flowed. Also, that water that rains and goes across parking lots and driveways has a lot of stuff in it. Then, of course, we have the water that goes through sewage treatment plants. So it's all of the wastewater from our house. Somebody had asked, is there a limited amount of water? Will we run out of clean water? Well, we could if we're not careful. And so one of the things we do to reuse water, as disgusting as this might seem, we actually take the wastewater and instead of what people used to do, which was dump it in the oceans, we clean it, we treat it. And so you filter out all the big nasty stuff first, and they actually use some of this filtered out stuff as fertilizer for fields. So first filtration, then you treat it with these absorbent type materials that stuff sticks to and let that nasty stuff settle out. Then you filter it again, and then you chlorinate it. Chlorine we put in swimming pools, of course, which kills bacteria. You have to have chlorine in the swimming pools because everybody's bathing. You've got bacteria on your skin, and little kids pee in the pool. And so you have the you have the chlorine to kill all that bacteria. There is chlorine generally in your tap water. Sometimes when you turn on the water, you can actually smell a little bit of chlorine smell. The thing about chlorine is it's very volatile, which means it goes away quickly. So if your tap water smells like chlorine, which sometimes it will if the water treatment plant has to add more stuff to it, if you just put it in a pitcher, a gallon pitcher, whatever, and let it set out even for an hour or two, that chlorine taste goes away. But they also use UV light for sterilization and other things. And there you go. And we'll look a little bit at that tomorrow as well. But depending on where you live, here in Boulder County, most of our water is really fairly clean and not very treated because it comes from reservoirs up in the mountains. If you live somewhere else out on the plains, you might have more water that comes from systems like this. All right, and that is the water cycle and all the important stuff you need to know. So let me know if you have questions on that.